Done, guys. Can we check now the pod? Here, one of the pod, you take it out. kubectl, kubectl, http. See v1. Now it rolled back to v1. So it has a many features. Deployment is a many features, and which you all use it for deploying the pod. So how to deploy the pod? You have a pod, replication controller. We have a deployment, but we have some more. I want to give you some task for it. Find out what is a replica set. All are easy actually. Okay. What is a daemon set? Okay, find out this one. All are easy, trust me. And then one more, which is we have stateful sets. So, did you understand that? How do we deploy the pod, all of you? Okay, so now next topic which I am going to cover is called network load balancing. Okay, network load balancing. Concept I think I feel you should know. You should be knowing it. But in Kubernetes, what we call it, service. So what is service? Service is a network load balancing. So what we need? So look at this, understand this flow. It's very simple. So right now you have multiple worker, 1, 2, 3, and multiple pod of Apache is running, 1, 2, 3, 4. Let's say some database pod is also running here. So now this black one is application server and red one is your database. So now let's talk about how this application will connect to database. That is a question. Are you understanding, all of you?
Yeah.
So which one you want to connect? You want to take this from here or here? And you saw that in a deployment, IP address of pod will change if you do the new deployment. And if you delete the pod, it will replace the pod with a new IP address. So what to do? So nothing great we are going to do. This is your cluster, boundary of the clusters. Okay. So what you are going to do is you are going to create one service which will load balance this pod. Agree with me? This service will have IP address. So now all the front end pod will talk to this service, and this service will decide where to transfer to here or here. And this will become a fixed IP address. Did you understand that?
Yeah.
Are you understanding, all of you?
Yeah, Rajesh.
Yeah. So the question is, how do we create a service? Let me tell you guys, service itself is a one day of course. What is service? How it works, property of service, types of service, and difference. But I'm teaching you in the simple way, so you'll get started with it. Okay. And the detailed video you have in LMS for each and every topic in tagged way, like service itself, 1.5 hours of video you have it only on the service. Okay, so it depends on that. If first you go through my recording, practice it, once you get comfortable with it, and then you want to be expert in each topic of Kubernetes, then go through the individual videos for it. Okay, so here I want to create a service which should load balance these two pod. Okay, so I had to have a two deployment, right? So can we deploy the two? One is front end, one is back end. So get deploy. So this is my deploy. I'll delete this for the sake of it. Delete deploy my dep. So I want to create one deployment from front end. Okay, so this command named it front, and one more 3 pod you have it, and one more back. Okay, that's all. So here there's another pod. So this you have a front end, this is the database. Just imagine this. So can we create one deployment? Done. kubectl get deploy. You got the front and then you got a back end. So 336 total pod you have it. Now fighting between that, which one will talk to which one? See here. QCTL. Which one will talk to which one? That's the fighting. Okay. So what we do in this case? Terminating while taking time. Should be done faster. QCTL. Get notes. I'm not sure why this is unhealthy actually again and again. Anyways, I have a master acting like a worker, but this guy is becoming an unhealthy again and again. And why? I'm not sure actually. So I gave them good RAM. Little bit of load also is not able to take it up. Okay, anyways, I'll not troubleshoot now in front of you. It can be anyways. Okay, so I restarted this automatically. It'll correct the stuff. Okay, so now see that here, all this pod you have here, and this is the pod. So a back end and front end. So what I will do, I'll create as per the discussion. This is the back end. So I'll create one service for backend. So can I create a service for backend? Now the question is, how can we create? So for that, kubectl create -h, because I don't know the command. So I will ask the kubectl, hey kubectl, tell me the command for creating a service. So here's service here. Now service -h. See, I'm learning myself. What type of service? So here, I will not confuse you too much. You go for this service. So the beauty of this service is, this service will create a service. I mean, this service, clustered IP service, will create a service which will be accessible only within a cluster. I repeat, this service will be accessible only within a cluster, which I want, because these all are inside a cluster, not outside. So yeah, I'll go for cluster IP -h. -h is a magical command. And now this command will help me to create a service. Service means load balancer. So name, what is the cluster IP type, mycs, what is the service name, what is the port number of containers, so 80. Service port number, I'll let it be anything. So clear the screen. Now I create a service. And how do I see the service? kubectl get svc. And here there's a one load balancer which is available already. This I'll give you a project. Okay. I mean assignment. Find out why this service is there. I did not create it. When you set up a clusters, you will have that service. So why that service is there? Try to find out. This service which I created, and this service is load balancing how many pod. Let me describe all the command. You know that same command actually. There's no change in the command. Okay, so this service is, you know what this service is, I created a service, but you know what, I'll tell you. Get pod. Look at this very carefully. It's very interesting topic. Okay, show labels. See here, and backend, only backend. Okay, look at this backend. So see here, labels of backend pod and selector label, which is where that here. Is it matching? Tell me. Is it matching anywhere? Hello?
No.
So the magic here is, see here. So this service I created successfully. Wonderful. It's like this, I'll tell you, simple way. I created a load balancer in AWS, but I have not attached an instance to it. Have you tried that?
Mm-hmm. No.
Yeah, so same scenario. So I created a load balancer like a service here, but I have not attached to the pod. How do I attach? So this service is saying, hey service, I will pick it up. Please listen me out. Hear me out. Service, I will load balance all the pods. Where? This pod. Only if the labels of this selector label of service matches with the labels of pod. I repeat, service will load balance. I'm putting in a more simpler way. This service will load balance. Here it is an endpoint. Only those pods where selector labels of service is matching with the labels of pod. It's not matching. So what to do? Nothing great. I'm going to edit that service. Edit. But the selector labels. What was that? I forgot that. Back, right? Yeah, back. So cluster selector. Yeah, here. Back. See, I'm as this, and the magic you see. See. So whichever the selector label is matching with the pod labels, load balancing is happening. So now, if you hit the service curl HTTP and here and this is the port. What is the service port number? 5678, right? 5678. Enter. Now see, one of the pod is displaying. One of the pod out of which this one is displaying V2. Welcome to V2. All three ports are saying, right? So load balancing is working fine, no problem. Are you understanding, all of you? So same way, I now what is there? So now you know what? I created one service which is load balancing these two pod, and now the front end pod will be configured with this IP address, and now that way traffic will be decided. Let me show you the get service. QCTL get SVC. See here, this is the service IP address. This is the port number. So when you hit this one, you will have one of the pod is available for your service. Wonderful. So now I'm going to hard code this IP address and this port number in the back end. Front end pod. So front end will talk to here. Look at this arrow here, here, and here. Are you having good visibility?
Yeah.
Okay, so now this is one, but how to be front end can be accessible. So front end for that, let's say end user is outside, not inside a cluster. So how can he access? So he cannot access the pod directly, and he cannot access the service directly. Okay, so what to do? So let me first create a service for front end. How do I create a service from front end? You know that here this is the command for that. So same way you change the command and do the same thing with the backend. Front end you will create it. But now I need something else. Because even though I cannot, let's say one service you create here for the front end, and this will be load balance this pod. So this guy cannot access this one. Why? Because the scope of service and the pod is a clustered IP only. So what to do? So can you access this node network? Node network, yes, I am able to access. That's the reason putty and all is working, right? So what to do? You create this service and expose. Hear me out. You create this service for the front end and then expose at the node port. Just port forwarding, which I did, no? Same way. Service can be port forwarded also. So expose at the node port and this guy can access. So how do I create? That's a question. How do I create service? How do I create service which will help me to expose at the node port? So the type of the service should be node port. Simple. So this node port, what will do? It will do two things. It will create a service, clustered IP service, and expose at every node of the cluster, so I can access from outside also. So for that you have to use the node port. So if one service which you want to be accessible within a cluster, use the clustered IP. If any service which you want to access from the IP address of node, use the node port. Now you have two more. I will let you explore this one. Okay, so what to do? Nothing. You know that very well. Node port -h, and this is the command, and here creating a node port service ns, container is running, pod is running with the 80 port, and done. Now creating a service scope with node port. See here. So this was a cluster IP, but here you see this is type node port. Node port also have IP address clustered, but that this service which I'm talking about get exposed at the node port at every node of the cluster at this IP address 31241. That means if you hit the IP address on this port, you should get to this particular address, and this particular address will get you the pod. So I have not matched the collector node. So let me do that. Pod. So here backend pod, front end pod, front. So I'm going to edit that service, and here np, right? No, ns, no ss, and front, right? F front, yeah. So selector label front. Okay, done. And now let me front will have a, let me first try this is working or not. So curl http dot 5678 this service curl is spelling mistake. Oh, kubectl. See v1. So this is this cluster IP is working. Now this port number you have to try. So from outside, and see which pod you are getting, we don't know. So guys, this is a way it works. The service is equal to load balancer. Are you understanding, all of you?
Yeah.
Okay, so now guys, I taught you only 4-5 objects, which was the most important one, which you use 80% of the time, like a pod, replication controller, namespace, deployment, services and all. But we do have a lots of other resources also. Okay, so slowly, I would request you to practice it and get into that. Okay, so now we'll have a break now, and after the break, I'll teach you Helm. Helm is a good tool to work with in Kubernetes environment. I'll teach you that one. Okay, so any questions before going for the break, all of you?
No, I'm good.
Okay, guys, so let's have a 15 minutes of break, 1-5. And after the break, once we come back, I'll teach you Helm. See you. Bye.
Thanks for watching. Want to study further? Join our training programs today.